In the whirlwind of today's digital ecosystem, data is not just part of our daily routine, it's the lifeblood of our operations. But as the volume of data skyrockets, so does the complexity and the costs of managing it. It's like you're being asked to move faster and further, but with the same old map and fuel that's burning a hole in your budget. You know the scene all too well. The alerts warning that your data storage is reaching its limits, the scramble to optimize resources without disrupting services, and the looming shadow of budget cuts forcing you to do more with less. It's a high wire act, balancing the need for speed and scalability with the reality of finite resources and escalating costs. But there is a way to rewrite the script, a way to harness the full potential of your big data, streamline operations, and slash costs, all while supercharging efficiency. In this webinar, we're peeling back the layers of big data complexity to reveal the secrets of optimization that have been right under our noses. Is Databricks the answer? And what are the practices for Databricks optimization? I'm Ganesh the Awesome, Senior Solutions Engineer at GlobalDots, and joining us today is Roman Yegorov, Director of Solution Engineering at Intel Granulate. Welcome.
Thank you for having me, Ganesh.
Totally great. So really looking forward to getting into this topic. Roman, kick us off. Tell us a little bit about the state of big data in 2024.
That's great. So as we are entered on already in 2024, we see a big trend of big data here this year. Many companies are moving to the big data market. And if we are looking on the value of big data on the previous year, we're talking about $270 billion of market regarding the analytics market based on Fortune Business Insight. And we're looking that 42% of enterprise scale companies actively deployed AI in their businesses. That's based on IBM Newsroom. And lastly, we see that 95% of the businesses manage to extract data and solve their problem actually with using those data to solve real issues in the world.
Okay, wow, massive numbers. I'm slightly dubious of the 42% of people saying they're using AI. I saw on LinkedIn just before coming on this call actually an AI-powered toothbrush. So I have some questions about where AI is not AI, but some very big numbers in there for sure. So walk us through, what are the four main challenges then?
So the first one is complex data workloads. As we see, more and more workloads are becoming big data workloads, which mean we need to get an approach of ETL or data ingestions or CDC to actually scale our workloads and try to uncomplex those, even though they're really complex. The second one is big data visibility and how businesses are gathering insights to make their business stronger. The third point is scalability, or how businesses are taking all this big data and actually combine them on a pipeline or on workload to actually make any insights out of that. And the fourth one is the dynamic nature of workloads. The workloads are changing dramatically. The data sets are changing based on hourly or even daily. And we need something to capture all those to get really good insights and business insights and business infos to make any conjunction and conclusions.
And your experience of being a senior engineer in this, and you come across it very frequently out there in the wild, how well are most companies doing with these four aspects? Or what's the percentage rate who have a good handle on these?
So actually, when we're talking about those 4 points, the main pain out of them is the cost. The cost is growing dramatically from the moment that any company entered into the big data section until they realize one day that they're paying 10 times more than the starting point.
Great. So then despite the fact that we have these four main challenges, really it boils down to one thing at the end of the day, and that's too much cost.
True.
So walk us through some of these optimizations for big data platforms.
True. So the easiest way is to understand where is your data or decellular the data. Then do any practices for cost analysis and cost monitoring. Then structure the use cases and try to be agnostic as possible to any use cases that you have, which mean run on one platform, combine the platforms that you have to single platform. Make sure that you have an automated orchestration for those. Either if you are using any tool such as Airflow or Azure Data Factory or any centralized platform that will help you to do the orchestration seamlessly and without any issues. And monitor and tune performance. Mainly when we're speaking about monitor and tune performance, we're speaking about better resource utilization or network performance, because sometimes latency and throughput are big things in big data because we're processing billion of bytes every day. Make sure that you have really nice data pipelines, that you are ensure seamless ingestions, processing, and storage for those pipelines and big data information.
People are pretty familiar with tools like Datadog, Coralogics, APM, and application monitoring, and open telemetry and open tracing. So these are very defined standards at this point. What sort of things are we talking about when we're talking about monitoring and tuning performance of big data? What sort of tool sets are in there?
That's a great question. And actually, there is many tools that the service provider can gather for you. Any small monitoring, such as CloudWatch, or any monitoring tools that EMR providing or Dataproc are providing as part of the pipelines. Better scheduling mechanism using Airflow plugins that can give you some visibility and governance on the jobs or the pipelines that you are running. On the network side, you should monitor your I/O, both on the instance level and the cluster level. Do some aggregation, understand what's happening when you are increasing the throughput or the storage, how it will affect your both cost and performance. Resource utilization is actually a big theme right now, and I think that we have a couple of slides to discuss that specific point.
And just before we move on, it would be really interesting again to get your insight as a professional in this. Roughly, as a percentage of organizations, what percentage of organizations do you think have a good handle on this? Like who are doing all of these optimizations in a good way?
Awesome question. It depends on how mature the organization in terms of big data journey. And we're talking about 35 to 60% out of the big enterprise who are utilizing big data pipelines on daily basis are probably at least did 3 out of those 5 points.
Okay, so lots and lots of room for improvement everywhere, basically. So talk us through some of these orchestration tools then.
That's great. So when company decide to start a pipeline or data pipeline, they usually will do the obvious. They will go to one of the cloud providers, will do some research, and will find that there is a managed service which can help them with their yarn resource allocation. So they will just spawn up a regular cluster with a yarn technology. Yarn technology will have a resource manager, which will do the orchestration for all the resources that this pipeline or big data job require. Then more and more big companies discovering the power of Kubernetes and just using Spark Operator as their main resource orchestration tool. The big advantage of using Kubernetes as your provisioning tool is that Kubernetes is much easier to use for DevOps engineers. So you don't need to go and do some research on Yarn and understand how is Yarn actually allocating the resources, how the JVM of Yarn is working, different allocation of Yarn, different versions of Yarn. Everything is available through Kubernetes. You can easily manage your namespaces. You can easily manage your segregation and performance stability. On top of that, in Kubernetes, you can easily isolate any analytics or any workloads using a namespace, as well as get a better segregation and performance stability using different namespaces. That's the big advantage of Kubernetes. Then the last one is Apache Mesos, which is open source program, which actually using Mesos scheduling algorithm for Spark, for example. It's implement the fine-grained resource sharing and monitor those resources to make sure that the task scheduling are done on the most optimized way. The big problem with Mesos is that you need a dedicated person who will learn and understand how Mesos is working in details to do all those great orchestration that Mesos comes with.
And I think enough organizations probably struggle to find Kubernetes engineers, let alone trying to find Mesos engineers. So I imagine that's distinctly less popular. Would be interesting to know. Obviously, you can take Kubernetes as a service from any main cloud provider. So, example, AKS, something like this. Do we see the same for Yarn and Mesos?
Mainly for Yarn, you have EMR by AWS or Dataprog by GCP or HD Insights by Azure, as well as Cloudera, who are the leading service provider for those kind of workloads.
Mhm.
You can easily migrate from each one to other. All those managed services are also coming with great auto-scaling capabilities, which can help you actually scale in more efficient way. Allocated more or less workers to make sure that your data pipelines are getting and not breaching any of your SLAs. Because eventually we want to make sure that your SLAs are on place and you still paying the right amount of money to the service provider.
And Kubernetes, to somebody, to the uninitiated in this world, Kubernetes would seem to make obviously the most sense. But would there be any downside to that as opposed to using one of the other two?
Of course, so Yarn is the most easiest to use. You can find any templates, any open projects, such as Spark, Hadoop, Flink, or any other project by Apache. You can spin a job with a regular ingestions or ETL within 5 minutes. With just browsing through GitHub, you will find the best way for you. In terms of Kubernetes, it's quite similar, but the problem in Kubernetes is that you have some limitation on storage and you have some limitation on pod scheduling, and those can really affect the SLA and the data governance that you have on Yarn, which you will not have on Kubernetes.
Thanks for that. That's really great insights. So let's talk about the why. Why the move to Databricks?
Actually, Databricks is one of the most great companies there in the field. They're making sure that you, as a regular engineer, will have all the capabilities that data engineer have in his hand. It has collaborative workspace, which means that you can have easy work with your friends. You can share scripts, you can share jobs, you can share runs. Everybody on your company can see it. It supports multiple programming languages from Java to Scala to Python to R. Whenever is good for you, go for Databricks. It integrates with popular data storage and processing system. With just 2 clicks, you can integrate it with your lab storage or with your S3. You can ingest data from S3. You can pull data from S3. You can create data lakes really easy, which is sometimes was a really big issue on those things. The most important thing is that managing everything for you end to end. A to Z, they're provisioning everything for you. And as it's mentioned on the last point, it's one-stop shop. You have any kind of solutions from regular jobs to all-purpose cluster to interactive clusters through an SQL engine, everything in one place with really nice UI and very easy to work API integrations.
So sounds like a no-brainer and sounds too good to be true. And in the same effort as previously, what would be a downside of it? Why not move to Databricks?
So the main reason that you will not move to Databricks is the fear of missing out. I'm just kidding. Actually, everyone is moving to Databricks because it's easy. They're having really decent prices at the beginning. And then people are realizing after a year of using Databricks that their cost went from X to 100X within a year.
Well, sounds like a good business model if you're Databricks. So great news.
That's true.
So then we need to talk about the optimization there. So talk us through how we don't end up with a 100x bill.
So let's go from the easiest to the most advanced one. The easiest way, or the low-hanging fruits, is just turn off the cluster that you're not using. Cluster in Databricks are automatically scheduled, so just turn it off, click disable, and you will save money. Then track your cost. It's very easy. You have dashboards and exports both in AWS and Azure. You have Cost Explorer in Azure. You have CloudWatch and Cost Explorer in AWS that will give you the certainty of how many money you're paying for each one of your runs or each one of your jobs. Make sure that you are doing regularly audit. In quarterly base or in monthly base, do some audit and make sure that there is no jobs that are just in idle mode and idle state, or just ingesting data and you paying for that money. Share the cluster between different groups. You can use the same cluster both for your data engineering team and your insights team. If we're talking about the cyber industry, all the researchers can use one big cluster and save a lot of money on that. If you're doing any event detection or fraud detection, you can use the same cluster for that. Then we can see the 3 points that are on the bottom of the page. Enable spot instances. Sometimes spot instances can save you up to 80% of your infrastructure cost. So use it. In part of the jobs, which Spark Shuffle, which is the component that are doing processing on different instances, will not be able to be using Spot. But in 70% of the use cases, Spot will save you up to 80% of your infrastructure cost. Databricks have really good engine which called Futon, which is doing acceleration. Instead of compiling the Spark workers in Java, it's compiling them on C++ and making sure that the execution time is faster by almost 3 times. And the last but not least, use our solution, Intel Granulate solution for autonomous optimization for Databricks, and make sure that your cost is going down seamlessly and easily.
That's, it's very interesting being in the world of FinOps for at least 6 years now, and the first 5 options of the 7 options, you could use them for almost anything. It's the same story with VMs. It's the same story with attached drives. Everything. It's quite amazing that even at the very high end of Databricks, that most of it is really about making sure you've turned off things that you're not using, making sure that you're auditing who's doing what, and using the most cost-efficient resources underneath inside your cloud provider. So very cool. The photon acceleration is actually very smart. I recently saw somebody who was doing something very similar for Kafka, and they did a similar thing of turning JSON messages into flat C++ text messages in order to speed that up. So I see a lot of this like language translation in order for speeding up coming into the market, which is quite exciting. There seems to be a lot of that at the moment, like where you've written sloppy code, or you're somehow added bulk into your system. People are helping you to remove your bulk basically in an automated way. Great. So we're pitching hard here, and so we can say we use Granulate's automated technology. Walk us through this test case or this use case with American Airlines.
Great. So American Airlines was struggling with the cost, and they did anything that they could. They utilize spot instances. They get a really good saving plan from Databricks, as well as from Azure. That was doing some storage tuning, and yet the cost was growing continuously. And unfortunately, with Databricks, the cost is not growing linearly. It's growing exponentially. So It's going from $5 to 10 to 25 to 600.
It's the hockey stick. Yeah.
That's true.
Yeah.
Really nice reference to the airline team. So the challenge with Databricks is what was that the data engineering team was looking for actual good optimization that are simple to deploy, managed by itself, and still delivering significant cost saving and improving performance. So with Granulate, American Airlines was able to optimize their data lakes jobs and the Futon jobs by almost 37%, which eventually lead to 23% of average cost reduction across 300 clusters that Granulate was active on. Those optimization reduce cluster uptime and required resources, or if we're talking on more official language, it lead to a shorter job completion time to each one of the jobs, which are thermal jobs, and less resources for the interactive cluster, which is running always. The main benefit is that cost and the performance that Granulate was delivered autonomously was done without any additional code changes or any infrastructure changes on American Airlines side, and it was able to save 23% across all those environment.
So
Annually leads to almost $1 million. So it's a really big numbers.
So that's an amazing use case. And I'm sure somebody like American Airlines had some pretty clever guys on that already. So you talked about having 300 clusters and they were optimized. What sort of time frame is a project like that going to take?
With or without Granulate?
Both. Let's hear the answer.
So it depends on the engineering power and time that the engineers have, but usually it will take between 5 to 8 weeks to do all kind of optimization without Granulate. And with Granulate, you just deploy the agent on workspace level, the agent doing segregation based on clusters or jobs. And then within 2 weeks, you will be able to activate the agent and see those optimization in place. So basically with Granulate, it will be about 3 weeks, and without Granulate, it will be about 8 weeks.
Okay. And that's assuming that you have the top Databricks experts and they know what they're doing, which I would say probably like 90% or plus companies definitely don't know what to look for in optimization. So that's 8 weeks if you're sure you know what you're doing. Okay, so it's very cool, very swift, very quick technology. No code changes is something that is, again, with technologies and people's adoption of them, I see so much push now for zero code changes, and the industry is definitely moving towards that sort of way for a lot of products. So definitely speaks to me. So we have the high level results from this optimization, but let's look at the proof, and the proof is in the pudding. So talk us through this graph we're looking at.
Great. So what you see here is a snapshot of American Airlines data lakes job clusters. We're able to see here 2 different lines. This job is running on daily basis, on an hourly basis, I'm sorry. And you're able to see here any run that are segregated here. We're able to see 2 different lines, the orange line, which mean with Granulate, average course, and the blue dotted line, which means without Granulate optimization on. And we're able to see that using Intel Granulate, American Airlines was able to use 37% fewer resources.
Then we don't need any more proof than that. Basically, that's the magic sauce, and the magic sauce is definitely working there. So very powerful. So then talk us through like the high level of optimizing with Intel Granulate.
That's awesome. So Granulate actually has 2 capabilities built in on one agent. The first one is our bread and butter, which makes sure that Granulate agent will improve the cluster or the job performance, which means that the CPU will be reduced, the job completion time will be faster, and it will have a better concurrency.
Great. When we talk about the agent that's on there, how impactful is that on a cluster? What does that actually look like from the customer point of view?
So he mainly will join from shorter job completion time or lower number of cores per one job run. Let's assume that before Granulate, he had a hourly job, which was doing an ingestions of data. Let's assume that we are handling the same data every hour. And before Granulate, the job was executing within 15 minutes and was utilizing 10 cores. After Granulate, it was utilizing and finished by 9 minutes and utilizing only 8 cores. So the accumulation of both shortage of completion time and usage of fuel resources will come into the knowledge that the customer will pay less money to Databricks.
Great. Sounds like a win-win. And then let's talk about what this looks like in a continuous setup mode with inside an organization then.
That's great. So additionally to that, Intel Granulate agent is able to do a continuous resource allocation in more efficient way, both on the JVM runtime using better crypto compression acceleration or using better yarn resource orchestration, as well as playing with the memory arenas of the cluster, of the JVM, sorry, as well as utilizing Spark dynamic allocation to make sure that we are bin pack more executors on one instance and applying a better auto scaling for the customer.
And I typically have lots of in the world of sales, I have lots of people who have reservations about agents and the impacts of agents and the overheads that they create and things like that. What would you say to anybody who has these sorts of questions?
That our agent is very slim and does not eventually we are improved performance company. So if our agent is getting too much overhead, we're not doing our job well, right?
This would be very embarrassing if the main slowdown was your agent. Yeah, I have to agree with that one.
That's true. So breaking down the actual optimization that Intel Granulate is able to do for big data workloads, our stands for better yarn resource allocation, or in other words, continuously optimize the yarn resource CPU and memory utilization to improve the cluster density and remove any over provisioning waste. It can be done on dynamically yarn containers or in static environments when we are changing the input size of the cluster and the utilization constraints. The second thing is better Spark dynamic allocation, which means dynamically allocate and remove executors based on the job patterns and the predictive idles that the agent is able to learn due to some Spark heuristics, and optimize the executor scale up and scale down velocity by optimizing the window size and threshold to improve the fitting of each job pattern. Or in other words, make sure that you have the right amount of executors to execute the job as fast as possible while paying as low as possible. The three other section that you see here is crypto compression acceleration, or making sure that any libraries of compression, such as zlib, snappy, or LZ4, are using the optimal configuration to make sure that your job is executing as fast as possible. Playing with memory arenas parameters, such as making sure that the GC algorithm is perfectly having concurrency for your job or your cluster, or making sure that the native function of the GC are applied and you have both regular and parallel logic in place. And the last but not least, better JVM execution. The agent is able to execute control flow on the JVM level to make sure that there will not be any GNI or any unnecessary pooling or caching that will make sure that your performance is best.
Wow. So that's a very full set of continuous optimizations there across a very large array of things. I wouldn't like to be a data engineer who has to look for all of those settings myself, to be honest. So I definitely see the value in that. Let's talk about the different kinds of workloads.
So specifically for Databricks, our agent is able to do three main things. We spoke on the past slide regarding big data optimization. For Databricks, we have specific ones. The first one is the runtime optimization that I was just showing as last 3 points on the previous slide. Improving job completion time, making sure that you are utilizing less CPU and each one of the worker nodes are able to process more data, or meaning that the throughput will be increased. Then help the cluster get the right amount of workers nodes, which mean instances, to make sure that you still execute fast, but you're paying lower number of DBU and node for your cloud provider. And last point, if the customer is using auto-scaling by Databricks, we notice that the auto-scaling is very aggressive, and Granulate Agent can smooth the auto-scaling or make it a bit more seamless.
So let's have a look at this super slick auto scaling then.
Great. So it's not a rocket science eventually. It's based on heuristics and on actual value that our agent is able to query from Databricks API. As you can see on the blockchain downstairs, Granulate Agent or Granulate Backend is actually querying Databricks API continuously and asking from Databricks, hey, are those workers actually doing something or they're in idle mode? If so, please decommission them or change the amount of instances for this job because we know that the data set will be higher because eventually we are hooking as part of the Spark submit task for this job or this cluster. So our agent will be able to change continuously the number of workers. We'll update it both on Granulate Backend and on Databricks API to make sure that everything is aligned both in Databricks and on our UI.
Great. Sounds like a very nice way to have a more performant auto scaling environment. Obvious question would be here, why the Databricks themselves don't ask the same questions of their API? What's the slowdown? What's the reason why they're not it's not efficient by nature?
They're actually doing that, but by nature, they have some slower algorithms, let's call it like that, because eventually they want to make as many as possible revenue. So those 5 minutes difference will probably not cause that much harm for the customer, but it will cause a lot of revenue for Databricks.
Yeah, I somehow doubt there's a conspiracy theory in there that they did it to make more money, but I can definitely believe that that's not where they would put their R&D money. Let's put it that way. So then, talk us through this this auto scaling behavior chart then.
So what we're able to see here is the entire workspace of the customer, which is enabled with auto scaling. We're able to see here 2 different lines. The first line is the provisioned resources, which is the orange line. And then the second line, which is the blue line here, is the cluster utilization. And we can see that there is a slightly gap between the actual provisioning and the actual utilization. This gap is, I mean, it's not that big. It's about 10 to 15%. But if we were to do an integral between all those gaps over time period of 2 hours, the customer will pay more in about 25% because we accumulate both DBU cost and VM cost.
Makes sense. It's small differences when you're paying large sums of money for infrastructure do make a big difference in the end.
That's true. And what Granulate Agent is able to do is described on the following slide. It's actually able to better query Databricks API, understand the patterns of the application or the job or the cluster, and in better way provision those resources. So instead of 10% gap, it will be a 3% of gap, just to make sure that we have enough resources for the job and no job will failure due to the fact that Granulate Agent is doing any optimizations. While the customer will pay about 17 to 20% less for the same job or cluster.
Nice. So on the on this chart that we're looking at here, just so we're totally clear. So the blue line across is the blue line is what's actually being used. The yellow line is what granulators provision, so just slightly more than the cluster needs. And the red line is the original.
That's true. That's the provisioned resources by Databricks. The yellow line is what will be with granulate changes, and the blue line is the cluster utilization, or what actually is happening on the job level or cluster level.
Great. So then that's a super nice, you can immediately see the amount of waste between the yellow line and the red line. Again, you can't argue with data like that, basically. That's a great walkthrough of what the landscape looks like at the moment and how people can go around optimizing that, and particularly how Granulate goes around optimizing that. Someone who's in the world of big data every single day, what do you see as the future for either big data or Databricks, and where are we heading?
So there are two main paths. The most advanced companies will probably move to using Spark over AKS or EKS or any other managed Kubernetes service, because that's the future. Yet it's not mature enough to use big data pipelines or actually doing big ingestions, which Databricks can solve. So we will be able to see that more and more people are either going use Spark over Kubernetes or use Databricks as a managed service, which will save them a lot of time and money in terms of engineering power.
That makes perfect sense, and you get like 10 bonus points for not using the word AI in your answer. So that's totally great. Roman, thank you so much for walking us through. Real pleasure. You are a total expert, and really good to have your insights on there. Pleasure talking to you, and thanks for coming on.
My pleasure, Ganesh. Thank you for having me.
Thank you all for watching and listening. I'm Ganesh the Awesome, and if you're ready to deep dive and start transforming the way you approach big data or any other cloud practices, then the team and myself at GlobalDots are at your disposal. It's what we do, and if I don't say so myself, we do it pretty well. So have a word with the experts, don't be shy, and remember that conversations are always for free.